Okay, so you finished page 2. You got it all glued in. It's not going to fall out when I come around to check it. You're going to flip the page. And on the back of where we just did page 2, guess what we're going to do? Page 3. So make sure you get that done. Okay, page 3. You're going to go back in your folder and look for the one that was like this. We already cut this one out. We already cut it out. And we're going to get this one, all about atoms. That's the one you want, all about atoms. It's going to look like this. So cut that out. Pause the video if you need to catch up. And we're going to get out this one. All about atoms. Okay, you're going to need your trusty rusty highlighters again. Now let's zoom in. Let's get this in focus. Okay, all about atoms. Woo! Let's read to ourselves. Just kidding, I'll read to you. But feel free to read along. It will help you remember the information. So atoms, we remember, are the smallest part of an element that still represents that element. So that means that it still looks like that element. It still looks, smells, sees. So atoms are so small, you can only see them with a powerful scanning microscope. It's actually called an electron microscope, usually, because it's so small you can see the atoms. So all matter, solid, liquid, gas, and plasma, are made up of neutral or ionized atoms. So that means, like when we were talking about in class, how I didn't want to have a positive or negative charge. I wanted to be neutral. It's like that. Atoms are combined to form molecules. Molecules are a topic that we're going to start talking about after we finish talking about atoms. Atoms contain a dense positive nucleus surrounded by an electron cloud. So the electron cloud are all those electron racetracks. And the positive nucleus has the protons and neutrons in it. So it's dense because it's got all the heavy stuff in the middle. And we know that elements are found on the periodic table. That's that thing that I showed you in class. It looks like this, but it's a lot bigger. If you remember, when we were in class, I had a big poster that kind of looked like this, but mine was carbon. So we have the atomic mass, which is down here, atomic mass. And we've got, that's also known as the atomic weight. And it's the number of protons plus the number of neutrons, basically. We remember that helium had 2 protons and 2 neutrons. Perfect, because they each weighed 1. Then we've got the atomic number. That's this guy up here. It's the number of protons, and it's also the number of electrons. So see, number of protons. Protons and electrons are equal in most normal situations, in all 6th grade situations. So helium has 2 protons, and it also has 2 electrons. Okie doke. You're going to get some glue, and you're going to glue that in. Let's see if this fits. Right. Nah. Just right here at the top of the paper, like this. Beep. There we go. Okay. So glue that in there. And the next thing you're going to want to look for in your envelope is a piece of paper that looks like this. It says the atom. It's a half sheet. It's smaller. We're going to read this together, and then you're going to fill out the sheet that goes with it, which I will show you in a little bit. So you're probably going to want your highlighter. The atom. Atoms are the... Okay, we're following along. You've paused. You're back. Perfect. Let's zoom in. And I'll move it as we go. Okay. Do I have any volunteers to read? There's nobody in here. I'm talking to myself. Atoms are the basic units of matter. Matter is anything that has mass and takes up space in the universe. We remember that from the last page. The idea that all matter is made up of tiny particles was first suggested in 440 BC by the Greek philosopher Democritus. He called these particles atomos, which means not dividable or cannot be divided. In the early 1800s, a chemist named John Dalton built on this idea when he wrote his atomic theory. So remember, a theory is like a scientific idea that's based on a lot of facts and things that we already know. Scientists such as Ernest Rutherford, James Chadwick, and J.J. Thomson proved that the atom was made of even smaller subatomic particles known as protons, neutrons, and electrons. We know that. In the center of an atom is the nucleus. In the nucleus are tightly packed particles called protons and neutrons. Those are in the nucleus. Protons have a positive electrical charge, and neutrons are neutral and have no charge. Protons and neutrons have about the same mass and are said to equal 1 atomic mass unit each. So a proton is 1 and a neutron is 1. Atoms all have at least 1 proton in their nucleus. The number of protons in an atom determines what type of element it is. For example, all hydrogen atoms, that's the first on the periodic table, have 1 proton. And all helium atoms have 2 protons. The number of neutrons in atoms of the same element can differ. Hydrogen is the only element that does not have at least 1 neutron. That's why we skipped it when we were doing our demo, because it's kind of messed up. Electrons are negatively charged particles that move around the nucleus in electron shells or levels or clouds. Electrons have a mass about 1,850th that of a proton, so we just don't even weigh them. They're so very small and do not add much weight to the mass of the atom. A total mass of the atom is made up of the protons and neutrons in the nucleus. However, the nucleus is very small compared to the size of the atom. Most of the volume of the atom is in the empty space between the electron shells. We remember that when we were doing our demo, that we were putting the M&Ms in the nucleus and we were trying to pile them up, but they wouldn't stay in. So everything's really squeezed tight in there, and the electrons were just hanging out outside. A regular atom has the same number of protons and electrons. That means atoms are electrically neutral. The positive charges equal the negative charges. Hydrogen has 1 proton and 1 electron. Helium has 2 protons and 2 electrons, and so on and so forth. Later, like in chemistry in high school, you will learn how atoms can lose or gain electrons and become what are known as ions. So you might want to glue this in now, you might want to wait, but we're going to glue it into the bottom of page 3. So you're going to want to turn it sideways to glue it in. So get your glue out, put your glue on. Yes, I'm using tape, I know. It dries faster than glue. And you're going to put it in sideways like this. You might want to put it in after you do the next page because the answers for that are on there. So the next thing you're going to do is slide over to page 4. This one opposite page 3 so you can see them at the same time, because page 3 has the answers for page 4. So make sure you get that on there, page 4. And you want to look for this paper in your envelope 2. Be very careful because there are 2 that look the same. So make sure you get the one that says parts of an atom. Parts of an atom, not elements. Parts of an atom. And there are lots of blanks in here. I'm sure you see them. Guess what? You're going to be filling them out. But guess where all the answers are? Most of them are in here. So I want you to pause this video, get a pencil, and try to answer all of these blanks on your own. Once you've tried it once, then you're going to come back and check your work with me. So go pause the video now, try it on your own. Okay, so back on page 4, all parts of an atom. Let's check your work. All matter is made of tiny particles called atoms. Yup, you were right. Atoms are made of even smaller subatomic, that means smaller than an atom, particles called, yup, you guessed it, protons, neutrons, and electrons. If you didn't get those 3, I'm going to cry. We've been working on those same words for like 3 days. Okay, let's start with proton. Protons are positively charged particles in the nucleus that have a mass of 1 AMU, or atomic mass unit. The number of protons determines the element, excellent, of an atom. For example, hydrogen has 1 proton, helium has 2 protons. Cool. Let's move on to electron. Electrons are negatively charged particles in the electron shells, or levels, or clouds, or I like to call them racetracks. That's not very scientific, but I like it. The mass of an electron is really small. It is 1,850th than that of a proton. So it does not add significant. Significant means anything meaningful. Significant mass to the atom. Okay, neutrons. Neutrons are neutral. Remember, you can pause the video at any time or go back if I'm moving too fast. Neutral particles in the nucleus. Guess what? They both sound the same, because that's like the same thing. It's like that on purpose. Of the atom. They have no charge, and have a mass of 1 AMU. Remember, an AMU equals an atomic mass unit. Hydrogen is the only element that does not have at least 1 neutron in its nucleus. Wow, atoms are so small. The dot on this I right there, contains about 1 trillion atoms. That's like, it's huge. It's huge. I can't even describe how big a trillion is. Okay. So this is just another part. Atoms are mostly empty. Were you right? Space. The mass comes from the protons and the neutrons. Excellent. You were right, probably. In the nucleus. So once you've gotten all the correct answers, you can always go back and double check. Make sure you get this glued onto page 4. And congratulations, you're done with page 4.